Okay, so it splashes into the water, and we want to know what's going to happen to its speed and its velocity. Its velocity and its acceleration as it sinks.
Oh, it sinks.
Okay. So, yeah. So what's going to happen to its acceleration at the beginning? Okay. Asher. Oh, let's Ethan.
It'll keep accelerating. It'll keep decelerating until it gets to until it's going to reach the terminal velocity where the acceleration gets to 0.
What would that be kind of like? And I agree with that, right? The acceleration at the beginning would be highest, and then as you get faster and faster, you get more and more resistance, and you get to the point where you have no more acceleration. It would stop it from accelerating. Does that mean you stop?
It's just not moving any faster or slower than it was.
Correct. Okay. Do you guys know that aerospace engineers, the people that design aircraft, also design submarines? It's the same discipline. Because air and water are considered fluids from their frame of reference. Okay, so things are going to act just like if you jumped out of a plane, right? You speed up, but the rate at which you speed up gets lower and lower. Guys, let's put away the phones. Gentlemen. All right, so let's see what we're up to today. More to show you what a network machine looks like. You probably already know because it's right in the middle of the room. The whole idea is so that you'll be able to predict motion. So today you're going to make predictions and you're going to test those predictions. At the end of the period, in period 5, you want to have a lab summary. And I'll show you what I need from you today.
Summary.
Right, so it's not going to be a full-blown lab report where you can show me all your data and graph it out and all that good stuff. I want to know what you did and why you did it.
Why?
In a summary. Like, why did we choose to do certain things as opposed to doing other things?
Oh.
Right. We will follow a specific procedure. We want to know why we followed that procedure as opposed to doing something else. Okay, and how going through our procedure helps us arrive at our conclusions. So, all right, so here's the setup. I've got a very low friction pulley. I take this string off of it and give it a little toss, a little flick. You can see it'll just keep going because there's very little friction in the bearings. And this is a photogate sensor, and the photogate just sends a infrared pulse back between, or beam rather, between here and here. And it knows whether or not the spoke of the pulley is blocking it, or if it is not blocking it. So you can see the readout will go from blocked to unblocked and so forth. So the same people that made the photogate made the pulley, and so if you tap on this part of it, you need to set it to pulley mode. It's looking for this 10-spoke pulley. For you guys over here that did not see that, right up here is where you need to tap. I should have put this on the location. Yeah, but I can't. I'm tethered. Anyway, I'll show you that in a minute. Okay.
Is it the same motion thing
pulley mode
we had on this motion detector?
It's the same kind of interface. What it's doing is it's going to give you the same feedback as that motion detector. It'll tell you how position changes with time and how velocity changes with time. Okay. So check this out. If there is no friction in the bearing, in the axle, and I give this a little shove, what should happen? There's no friction at all. Yeah.
Stay at constant speed forever.
Yeah, that's right. Why? Exactly. Right? That's inertia. Okay, so let me give it a little tap and see if that's what happens. It stopped. What does that tell us?
There's friction.
There's friction. So I want to be able to determine how much friction there is, because if I don't know how much friction there is, then my predictions aren't going to be as accurate as they could be. So, we're going to have to figure out how to find friction first. I want you to model this system right now using a free body diagram. Call one side big M for its mass, and call the other side little m for its mass. And just draw a quick sketch of the system and try to determine